right, welcome back, students. This is Atmospheres week number 2, where we start really getting into global wind patterns and global storms. So, we're going to review a couple things. We're going to review what drives lift and the formation of low pressure, and we're going to look at how this is distributed around the globe by latitude. Well, let's take a journey over to our little whiteboard here. We're going to talk first about what is it that's driving lift, driving pressure formation. What is it that drives low pressure? Remember that low pressure is what typically gives you wet rising air, condensation, precipitate, and of course, wet weather. So right now it's actually, if you can't probably see it too nicely outside the window, but it looks all nice up there. But actually it's been raining quite heavily for about the last 24 hours here in Berkeley. And it's, yeah, been quite cloudy and wet. So what are the things that drive low pressure formation? And there's really only two that you're going to have to know for this class. The first of these is heating of the Earth's surface. Heating of the Earth's surface. The second of these is condensation and releasing latent heat. Latent heat, and that latent heat of the surrounding air drives buoyancy. Spoiler alert, the reason it is raining in Berkeley right now is because of the second factor. But we'll worry about that probably in about probably in a later portion of the lecture. For now, let's get started with our model of the world and global wind patterns, because this is going to be the big segment. So because the first driving factor here is heating of the Earth's surface, which should hopefully be fairly obvious to everyone here, is that the equator, you have these rays from the sun. You can see the rays from the sun, if they were evenly spaced, are a lot more concentrated at the equator than they are at the polar regions. Indeed, if you're at about 60 degrees north, you're receiving about half the sunlight per unit area as you would receive at the equator. And the further away from the equator you get, the more sunlight gets, more areas sunlight gets spread out, and the less sunlight per unit area is. So the equator, because it tends to get the most energy from the sun, will be this area of will tend to have rising parcels of air in it. And you're generally going to see at the equator a low pressure system. We're going to mark this low pressure system with a giant L. We're going to make the L bright red because we can. We'll give a name for that. So at the equator, you get this moisture-laden air. Rising. As it rises, it decompresses, it condenses, moisture condenses, the condensation releases latent heat, you get wet weather at the typically in these equatorial regions. Until eventually this rising air at the equator reaches the tropopause and then has to travels forward. You're seeing these little red arrows is rising air at the low pressure system. And what this will look like, if you're looking at it from space, is you'll see the formation of lots of big, tall, puffy clouds. Clouds of sort of anvil tops like we talked about in Thursday's lecture. And of course, I would not be right or doing this right if I did not also do some rain. It's generally going to be low pressure, and you're going to be getting wet weather at your equator. Now, as this air rises, this air that rises to the equator is then going to start to move poleward. Forward. So this air is going to start traveling forward. Forward from the equator. Now, in the polar regions, you have very, very cold air in the upper atmosphere, and you're going to and this cold air at the polar regions is going to be sinking. So at the polar regions, we have what is known as high pressure. Marked with that designated with an H. Oops, that was a little too big. Let's make that a little smaller. We have a polar high. High pressure designated by sinking air. As we get in the atmosphere of the polar regions is sinking air from the upper troposphere heading back towards the equator. And so if our planet were perfectly still, this would be what we'd have. We'd have a band of storms near the equator, and we'd have very dry, cold weather at the polar regions. Now, what you're going to do next is look at several videos. However, what we know about the Earth is that it moves. So what we're going to do in the next couple videos is look at how the motion of the Earth affects objects going from the equator toward the poles and from the poles towards the equator.